Hello and welcome back. In this episode, I'm just going to talk a little bit about the temperature scales and kind of show you how they derive the equations for converting from one temperature scale to another. Um, so here I have three drawings of the three different temperature scales. Now, historically speaking, there were like a lot of different temperature scales. But the ones that became the most popular were the Fahrenheit and the Celsius temperature scales. And there's a lot of history involved in why that is. And I'm not going to get into that, but it's interesting if you wanna read it yourself. Um, so one of the things you want to notice right off of the bat is the number of divisions. So the Fahrenheit scale is the scale that we see pretty much across the world, except for mainly in the United States, where we use or only in the United States, but outside the United States, we don't really see the Fahrenheit scale used. It's usually the Celsius scale. So for the Fahrenheit scale, um, the way you figure out the scale or do the scale is or create your scale is you would first take a thermometer that was unmarked, stick it into a bath of ice water, and then that would be your lowest point. So you stick it in the ice water and then wait for whatever the mercury at this point it was mercury, but wait for the mercury to go down to its lowest point and stop. And then you would take some sort of like maybe grease pen or wax pen and mark that level. And then what you would do is you would then take your thermometer and then put it into boiling water, right? And so the boiling water would then raise the mercury up to a certain level, but then it would stop, and then you would mark that point. And then you would have these 2 points, regardless of what thermometer you use, you have these 2 points, right? And then it becomes a decision about, okay, so how many increments are we going to divide this space into? Well, the difference between the Fahrenheit and the Celsius scale is the Celsius scale takes that distance and divides it into 100 sections, 100 equal length sections or degrees. The Fahrenheit scale decides to do that and divide it into 180 degrees. Now, I'm not sure why that is. The first thought that comes to mind is there's 180 degrees is the line through a circle. So if you cut the circle in half and you look at the circumference, that's 180 degrees. So maybe that is why they did 180 degrees. I'm not sure. 100, I'm not sure. Maybe it's a nice number. Again, there's historical reasons behind this that I'm not going to get into because I haven't researched it right now. But that's the main difference between the Fahrenheit and the Celsius scale. The other difference you want to note is the difference of where they start, right? So you can see that both these scales, from the freezing of water to the boiling of water, it's all positive, right? So it's all positive here, but if you go below that, then you get negative temperatures. Um, so they set the boiling of water at 212 degrees Fahrenheit and the freezing water at 32. So the lowest here is 32. You can go below, but 32 is marked here. Whereas in the Celsius scale, it's 0 and 100. Again, why 212 and 32? Probably there's historical reasons for that. And I'm curious to find out why. I should have looked it up before this video. So those are the main differences. For the Kelvin scale, again, if you remember from the last video, the Kelvin unit is the standard unit of temperature. So we're going to be referring to the Kelvin scale. If we don't refer to this Kelvin scale, we're going to be referring to the Celsius scale. So these two are used a lot. We don't really refer to the Fahrenheit scale unless you're doing a problem that requires you or asks you to convert from Fahrenheit to Kelvin or Fahrenheit to Celsius. Other than that, it's not going to be very much used. So one of the things you want to notice is that this scale here, the Kelvin scale, it's also referred to as the absolute scale. And the reason is because the lowest temperature you can get on this scale is 0. You cannot have negative numbers with the Kelvin scale. And it's set up purposely for that way. So the lowest temperature you can get is 0 Kelvin in the universe. Now, technically that's not true. You can actually get negative Kelvin, but that has to do with population inversions in having to do with population inversions regarding molecules and atoms and things like that, which is way beyond this course. For all intents and purposes, you can't have negative temperatures in the Kelvin scale. So this is the lowest temperature you have here is 0, but you can have negative temperatures for these two. Okay, so the other thing I want to note is that you'll notice that the difference between the boiling and the freezing of water is 100 degrees. Here it's 100 Kelvin. So the distance here is divided, both of these are divided into increments of 100, which means that the increments, degrees Celsius and Kelvin, are going to be the same distance, like the same amount, right? Whereas in this, since you have 180, you got to squeeze more lines in this distance here than you do here. So the increments of degrees Fahrenheit are going to be smaller increments. So in the same way that an inch is a smaller increment than a foot, because you can fit in 12 inches into a foot, the increments of Fahrenheit are going to be smaller than the increments of degrees. And so this 180 and 100 is going to be important. So with this, you can understand the formulas for converting from one temperature scale to another. So with the temperature scale for Fahrenheit and Celsius, well, let's just do Kelvin and Celsius first. So for Kelvin and Celsius, you have Kelvin. If you want to convert Kelvin and Celsius, you're going to do Kelvin is going to be equal to whatever Celsius scale you have, whatever degrees Celsius you have, and you're just going to add 273.15. 273.15. And you'll notice that 273.15 is this 273.15 right here, and this is 0. So you can see that if I wanted to go from 0 degrees Celsius to the same temperature on the Kelvin scale, then you can see, well, all I need to do, since they're at the same place, is add 273. So I add 273 to the Celsius scale, and I get my Kelvin here. Okay? So do you see that? And the reason that works is because the increments are exactly the same. So if these increments were not different, then the 0 and the 273 wouldn't be the same. Okay, or at least the lines would be the same, but this would not be the same as 273. You might have 273. But you might also have a factor, which I'm going to that you need to multiply. That's what I'm going to show you in a moment. So because the increments are exactly the same, then the increments line up, the Kelvin and Celsius line up. So the only thing you need to do to convert from one to the other is either add 273.15 or you subtract 273.15. So if I want to go from Celsius to Kelvin, then, or if I'm going to go from Kelvin to Celsius, then instead of adding 273 to Celsius, I'm going to subtract 273.15 from Kelvin, and that'll give me Celsius. So it's just a matter of adding or subtracting 273.15. Now, what about going from Fahrenheit to Celsius? Here you're going to have a multiplication factor because the increments are not the same. But you'll notice what is the size difference between the increments? Well, you know that this is divided by 180, and this is divided by 100. So because this is less divisions, then the increments, the size of the increments, are going to be proportional or inversely proportional to the size of the increments of the Fahrenheit, because Fahrenheit has more divisions. So the more divisions you have, the smaller the size of the increments. The less divisions you have, the larger. So the proportion, here I have 100 divisions versus 180. So what you're going to find is that in order to relate these two, this is going to turn out to be that the size of this increment is going to be 1.8 times bigger than this one, because I have to fit less. So the ratio of 100 to 180 is going to give me the ratio of the sizes in the inverse. So the size of the increments for your centigrade or your Celsius scale, they're going to be 1.8 times bigger than your increments of the Celsius scale. So that's going to find its way into the equation. So for the equation, you're going to have, this is one way to write it, Fahrenheit, degrees Fahrenheit, is going to be equal to, you're going to have degrees Fahrenheit, and that's going to be equal to 1.8 times the degrees Celsius. So whatever you have in degrees Celsius, you're going to multiply that by 1.8. So that's where the factor 1.8 comes in, the size of the increments. And then what I'm going to do is I'm going to add 32. Now, where does this 32 come in? This 32 comes in because of the difference here. So notice the 0 mark and 32. So I still have to add or subtract 32 depending on which direction I'm going, if I'm converting from Fahrenheit to Celsius or Celsius to Fahrenheit. So that's where that comes in. So that plus 32 is because of that difference there. The 1.8 is due to the difference in the size, and that comes from the fact of I have 180 divisions here and 100 here, and so I get that ratio, and that comes out to 1.8. So both of these formulas are what you use to convert from one to the other. And if you want to convert from Fahrenheit to Kelvin, then you got to use both of them. You got to use this one to convert from Fahrenheit to Celsius, and then once you get Celsius, use this equation to convert from Celsius to Kelvin. As far as I know, there's no equation that does that. Although you could actually solve this for Celsius, substitute that in there, and then you would have an equation for converting directly from Fahrenheit to Kelvin. But I've never seen that written out. So usually you'll see these two. So I hope that was informative and interesting. So next time I will be talking more about getting into conversion factors and setting that up. Thank you for joining me.